Okay, so in this question we're told ABCD is a quadrilateral. The angles ABD, BCD are right angles. The angle DBC is 44, DBC 44. The angle DAB is 36, DAB 36. BC is 8.5. Calculate the length of AD. So we're looking to find this length. Now, looking at the question, because they've drawn in two right angle triangles and they've given us some acute angles, we're thinking immediately, can we use trigonometry? But in this right angle triangle, at the minute, we don't know any lengths. So we can't use trigonometry at the minute to find x. Then we look at, they've actually given us a second right angle triangle and they have given us a length in this. So what we're going to be able to do is we're actually going to use that triangle to work out the length of DB. Okay, so we come into our diagram and we're going to label it hypotenuse, adjacent and opposite. So this is the angle we're working with in this right angle triangle. So this is the hypotenuse for this triangle. This would be the adjacent and this would be the opposite. So if we're going to work out the length of BD, we're going to be using hypotenuse and adjacent, so we're going to use cosine. Now, if you can't remember which of the two, I use this little silly word, toa. All it does is a rhyme for remembering each of the formula. And here we can see cosine of an angle is adjacent over hypotenuse. So in this triangle's case, we have the cos of 44 equals 8.5 divided by y, the length of BD. Now, in trigonometry, when you have an equation that looks like this, where the unknown is on the bottom line, you'll get the answer by dividing. Okay, so we know y is equal to 8.5 divided by cos 44. Okay, so that turns out to be 11.816 blah 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 blah. Okay, so now we know this length. So I'm going to change my colour of my pencil. So I now know this length to be 11.8 approximately. So in this triangle, this is the angle, so this is the adjacent, this is the opposite, and this is the hypotenuse. And I'm deliberately using three letters because I've moved this other triangle and I don't want to confuse it with this letters I used on the smaller triangle. So in this triangle, we're looking for x, so we're looking for the hypotenuse, and we know the opposite. So if we look at SOHCAHTOA, if we know the opposite and we've got the hypotenuse, we're going to be using sine. So sine of the angle is equal to the opposite divided by the hypotenuse. So in this case, the sine of 36 is equal to 11.816, etc., divided by the hypotenuse x that we're looking for. So again, we're going to get our answer by division. So x is equal to 11.816, etc., because I'm keeping it on the calculator, I don't need to change it, divided by the sine of 36. Okay, so that turns out to be so we can say then AD equals 20.1 centimetres to 1 decimal place.